A fifth degree polynomial with a positive leading coefficient and 3 real zeros. I will provide a couple of options. So one could be, let me change the color. Coming in from the bottom, touching, going back, touching, and then going through. So here you have 1 0, 2 0, 3 zeros. Or you can have it, let's see, touching, going through, touching, and going back up. So both of those, and you could also do one where it goes through first and then the last two zeros are touching. That's a third option. So here's 1 0, 2 zeros, and 3 zeros. Alright, so for 85, I just went back to the previous homework and found the zeros. Okay, so I'm not going to go through all the work of factoring and all that. You've already done it. So the zeros are 0, -3, and +3. I know that this one has, again, based on what we know and just looking at your old answer, it has a down-up end behavior, and all zeros have a multiplicity of 1, so all the graph crosses through the 3 zeros. And so now I'm just going to plug in a 1 or a negative or a 2 to see what I get for y. So we see here f of 1, replace your x's with 1, so you get 1 minus 9, -8. And then f of 2 is 2 cubed, which is 8. 8 minus 18 is -10. Okay, now another thing to notice here is that this function is an odd function. How do we know that? When you do the test f of -x. So all those little things that you've learned in the past are helpful, when you're sketching these functions. So this one is a -x cubed plus a 9x. So this is the opposite of the original function. So I know that if the point, so how does this help you? Well, if the point 1, -8 is on the graph, you know that point -1, +8 is also on the graph. If 2, -10 is on the graph, then we know that -2, +10 is also on the graph. So that'll help you when you're graphing your polynomials. So 1, -8, again, not to scale, and 2, -10. And as you saw in class, and let me just put in the -1, 8, it doesn't mean that 2, -10 is the lowest point. It could go lower than that, right? But for our purposes, we're just going to go ahead and connect it. Connect the points. And then just check with Desmo's graphing calculator to make sure, just to verify. And that's it for this one. So 87, the zeros are 0 and 3. 0 has a multiplicity of 2, so that means that it's going to touch. And 3 has a multiplicity of 1, so that means it's going to cross. This function is not even, it's not odd, so it's not going to be symmetric with the y-axis, and we knew that already because the only zeros are 0 and 3. But it's not odd either, okay, so that's also, useful information. So 0 and 3. So I know that at the ends it's going to go like this, oops, that. So I'm going to plug in a 1 and a 2. I think this is the one we did in class, but it doesn't matter. So I set it up to evaluate f of 1 and f of 2. So 1 minus 3 is -2. And then 2 to the third is 8. So I get 8 right here. And then this is 4 times 3, 12. So 8 minus 12 is -4. So I can put that here. So this could be -2. This could be -4. This doesn't look like a 2. And so now I'm going to plot the points 1, -2, and 2, -4. Okay, and I know that it's going to touch at 0, so it's going to go bounce off, come down, go through 3, and there's the graph. And I would just plug it into Desmos or a graphing calculator just to see if we did get the lowest point right here or if it goes lower than that. Okay, and that's it for this one. Alright, so 89 has 4 zeros, 4 unique zeros, 4 different zeros. I have plus or minus 2, plus or minus radical 5, which radical 5 is approximately equal to 2.2. So they're pretty close together. Their multiplicity is all 1. So the graph is going to cross through every single 0. The end behavior is down, down. And with a fourth power, well, with the function that we have here, when you test for even or odd, it turns out to be even. So that means that it's going to be symmetric with respect to the y-axis. So if we find one side, then we found the other. As far as addition, let me plot what we have right now. We have -2, +2, and then 2.2. Again, it's really close, and -2.2, really close right there. And I'm going to plug in a 1 just to see, evaluate a 1, a positive 1. So f of 1, we get -1 plus 9 minus 20. So that's going to give us, let's see, 9 minus 8 is, 9 minus 1 is 8, so -12. So we know that 1 -12 is a point, and so is -1 -12, because this function is even. F of 0, -20. Okay, so I'm going to have to extend this a little bit, and again, it's not to scale, so I'll call this -20, and I'll call this -12. Okay, so now I'm going to continue plotting. Let's see, 0, -20, 1, -12, and because it's an even function, I know that 1, -12 is also a point on the graph. So it's a down, down. So it's coming in through, and remember we pick the outermost zero, so like the radical 5 and the negative radical 5 for our end behavior. So it's going to cross, come back down, like this, come back down like that. So that's good enough. Again, go to Desmos or any graphing calculator to get a more accurate picture as far as how high these little curves go, but I'm not going to plug in like 2.1 to find out. Okay, so that's as far as we'll go by hand. Okay, so 91 has 2 zeros. -3 has a multiplicity of 2, so that's why it touches, and 3 has a multiplicity of 1, so that's why it crosses. The end behavior is down, up, because it's a positive leading coefficient with an odd degree. This function is not even and it's not odd, so it's neither. So that helps too, because you know that you're not gonna have symmetry with the y-axis, and you're not gonna have symmetry with the origin. Okay, so that's also helpful. So let's go ahead and sketch what we have. So we have -3 and we have +3 as my zeros. I know that from this side it's going to come like this, and then from the right side it's going to go out like that. Okay, it's going to bounce off the -3 and it's going to go through the +3. Let's pick a few values for x and evaluate our function. So for f of -1, I get -1. -1 squared is 1, so +3 plus 9 minus 27. So that gives you, let's see, 12, so that's 11, so minus 16. Okay, and then we have f of 0 is -27, and then f of 1 is 1 plus 3 minus 9 minus 27. So that's -5, -31. So it's even going lower on the right side. Okay, so I'm going to extend this a little bit. Let's see, -16. I'll call this -16. Then negative. I guess we need -31, -27. So negative. I guess we can count by. That's 4, that's 10, so I'll do -27 and -37. Okay, So I know that f of negative 1 is negative 16. F of 0 is negative 27. So it'll be right here. And then f of 1 is negative 31. So about halfway. And so it's going to bounce off of negative 3, go back down, and then cross. Something like that. Check with Desmos and you'll get a more accurate picture, but for our purposes this is good enough. Alright, so 93 has two different zeros, plus and minus 2. They each have a multiplicity of 2, so that means that they are going to touch. The graph is going to touch and bounce off. The end behavior is down, down, because it's a negative leading coefficient with an even degree. The function itself, g of t, is even, because when you do the negative x, you get the original equation back. Okay, so that tells us that it's going to be symmetric with respect to the y-axis. Let me just change here. I'm so used to using x and y, but this is actually t and g. Okay, not x, y. I've already went ahead and did g of 1 and simplified it, so I got and evaluated it and got negative 2 1/4. So then I know that without doing any more work, I know that negative 1 is also going to give me negative 2 1/4 because the function is even. So now I'm going to go ahead and plot the points. So 2 and negative 2, those are the only two zeros. The graph is going to touch right at those 2 points and bounce off. I forgot to put it here, but the y-intercept would be negative 4. So 0, negative 4, and then 1, negative 2 1/4. So about here, and then about here. Okay, it's not graph paper, so it doesn't look as nice. So then you just go in, bounce out, and then bounce back down. So if you were using graph paper, both sides would look exactly the same, or at least more the same than what I have here on the screen. Okay, so that's all you do for number 93. Alright, for 122, they just want you to indicate the degree of the function and the sign of its leading coefficient. Okay, you don't have to write out a function per se, just degree and the sign of the leading coefficient. So with number, or letter A, 122A, seeing that it's a down up because the left is down and the right is up, I know that it's going to be an odd degree and that the A is positive. Okay, the leading coefficient is positive. So as far as turning points, I've got 1, 2. So the formula is turning points equals, and it's in your notes, n minus 1, right? So if we have 2 turning points, that means that n has to be 3. So it's just one higher than the number of turning points. So the degree for this one is 3, and the leading coefficient is positive. For B, it's an up, so that means that the degree has to be even, right? And the leading coefficient has to be positive. Well, this one has 1 turning point, so 1 higher than 1 is 2. So the degree is 2, and the leading coefficient is positive. Letter C is an up, again because both ends, the left side and the right side, go up. It has 1, 2, 3 turning points, so that means that the degree is 4. Okay, and it has a positive leading coefficient. Okay, and then letter D, it's a down up, so it's another odd degree. Can't be even, it has to be odd. So I have 1, 2, 3, 4, and I already had the answers here, but I wanted to show you how I got them as far as the turning points go. So I count the turns, so there's 4, so that means that the degree has to be 1 higher, so there's 5. 5 is a degree. It could be higher than that, but that's the lowest degree we can have. And then the leading coefficient, because it's a down up, it has to be positive.